Welcome to today's session on chi-square test in statistical methods using R programming. The chi-square test is to find the correlation between two categorical variables. Okay, so for normal correlation we use correlation, that is for numerical variables. To find the correlation we use the correlation function, but for finding the correlation between categorical variables we use the chi-square test. Okay, say for example, if we want to correlate the gender of a person with the flavor of the ice cream they prefer, we use chi-square test. Okay, so for in our programming for chi-square test we use the library mass. Okay, so inside this library mass we have the data set called as cars 93. Okay, so this cars 93 is nothing but the data set about the sales of different car types in US. Okay, so based on its features, what is the sales of different car types. Okay, so for that we are going to first invoke the library mass. So I'm running this. So and let me see the first few rows of the cars 93 data set. See here, so you have so many columns and many rows. You can see the manufacturer, model, type, minimum price, maximum price, mpg city, mpg highway, miles per gallon inside the city, miles per gallon inside the in highways, the passenger capacity, fuel tank capacity, seat room, luggage room, etc. There are so many features in this data set. So let me see what is the number of rows in this cars 93 data set. It is 93. And let me see the number of columns in the cars 93 data set. It is 27 columns and 93 rows. Okay, so for applying the chi-square test we use the function chi-square, CHISQ dot test function. This is the function in our programming used for chi-square test. So this function expects the data in the form of a table. Okay, so we have to select for which columns we are going to find the correlation. So in our case we are going to find the correlation between the columns airbags and the type of the car. Okay, so the airbags available in the car and the type of the car. So these two variables we are going to find the correlation. So let me first convert that into a table and store that in car data. Let me run this. Okay, so now what does this car data have? The car data has the type of the car, that is compact, large, mid-size, small, sporty and van are the different types of the cars available in cars 93. And the airbag types are driver and passenger, driver only and none. Okay, so these are the air type categories. Okay, so the different categories of the car type and airbags are listed, and the number of components for each combination is given here. That is, for driver and passenger with compact car type is 2. There are 2 models available, and driver and passenger airbag with large type is 4. Okay, so likewise for the different combination of the car type and the airbags, the values are listed in the form of a table. So this is what we have in car data. Okay, so now we pass this car data to this chi-square test and we store the result in CHI, that is chi. Okay, so let me see what is there in the CHI, the result of the chi-square test. So it is only showing the p-value. Okay, so based on the p-value normally we decide whether we have a strong correlation or a weak correlation. Okay, since the p-value here is 0.0002723, so this is very less than 0.05, which is 5% level of significance. So this indicates that there is a strong correlation between the variables airbags and type in the cars 93 data set. Okay, so there is a strong correlation, that is if the airbag based on the airbag category, the type of the car is decided. There is a high correlation between type and airbags. Okay, so the type depends on the type of airbags in the car. Okay, the type of the car depends on the type of airbags in the car. Okay, so this is what we have seen using the chi-square test. So for chi-square test in our programming, we use chisq.test function. Okay, so this is how we find the correlation between two categorical variables using chi-square test in our programming. Hope it was a useful session. Thanks for your patience listening.